to counteract some of the challenges in using polyclonal antibodies, scientists decided to develop monoclonal antibodies. Monoclonal antibodies are obtained by isolating B cells from the spleen of an animal that was treated with your antigen of interest. So it is actually very similar to what we just discussed for the polyclonal antibodies, in the sense that you select a host, you inject it with the antigen, you give booster injections, but then instead of purifying that antibody from the blood serum, you're actually going to obtain the spleen of the animal, which is typically either a mouse or a rabbit, and you're going to start growing those B cells, establishing a cell line. Now, a cell line, as most of you probably know, could potentially die, and that is something that we want to avoid. To avoid that, what we do is that we're going to hybridize that B cell line with a cell that has been transformed and therefore immortalized, such as a myeloma cell line. That cell line is now called a hybridoma because it's a hybrid between the B cell and the myeloma. Once you have your hybridoma, you're going to start growing each one of those cells separately, so that you're going to have each antibody being produced in an isolated format, which will allow you to screen through those and see which ones will work best for your future assays. Now, because those clones are isolated and each antibody is obtained separately, now we have what we call monoclonal antibodies. Some of the advantages of using a mouse or a rabbit monoclonal antibody is that they're going to be highly specific, since you have selected that one particular clone of interest. Because of that, they're also going to have very low cross-reactivity, and they can be used in any isotype that you would like, not only in IgG, such as is the case for polyclonal antibodies. Of course, we also have to have some disadvantages to the use of monoclonal antibodies. They tend to be a little bit more expensive than your polyclonal antibodies, and it's going to take a little bit longer to produce them, and that production is more labor intensive. Because we're working with hybridomas that are immortalized cell lines, you always have the risk of contamination during or post-production, especially when it comes to the virus that may be used to transform your cell lines. If that wasn't enough, you still run the risk that your selected hybridoma cell line may be lost, and in that particular case, you may end up having variability between lot to lot.